Hello, fellow econometricians. Welcome back. We're going to do a quick video today from the point of view of a first-time introductory econometrics student who's been tasked with putting together a regression data-based project. So a previous video, we looked at extracting data, getting it into Stata from the World Bank, where we had country-level cross-sectional data. This time, from the same point of view, but we want to look at some of the issues with time series data that we'll put into our Stata software from the Federal Reserve Economic Database. So here is what we're going to try to accomplish in the next 15 minutes or so. Before you can start gathering data, you got to have a theoretical framework, right? So we'll just kind of look at a super simple example of how to put together a data generating process that will guide us towards the appropriate data to go ahead and capture. Then we'll go ahead and look at the source data. So we'll poke around the Federal Reserve Economic Database site, look at what information you want to extract from there, and kind of where to look, what some of the issues are. Then we'll jump into Stata, look at the nice, simple process of extracting that data, and then we'll look at the issues that result from that. So some data cleaning, mostly since we're getting started with time series here, it's going to be dealing with that date sequencing and some of the peculiarities that we'll see in Stata. And real quick, since we are dealing with time series data, here's my reference suggestion for the day. Introduction to Time Series Using Stata by Sean Becketti. I'm actually going to assign that textbook to my financial econometrics class this next go-around. Really nice, accessible for introductory students, but also lots of useful tips and tricks for the more experienced user. So thinking about a data generating process, we're thinking about a theoretical model of how a particular dependent variable is created period by period in our time series model. Now, again, you're generally going to want to put a fair amount of thought into this, but it might go something like this. I want to create a model that predicts unemployment, okay? So period by period, why in the US does unemployment go up or down? And then you want to think about what is the key causal variable, the treatment variable, if you will, that I want to focus in on. And you might say, well, let's think about how monetary policy influences the cyclical nature of the economy, measured by unemployment. So we might get that federal funds rate as our key indicator of monetary policy. But we can't make any sort of causal inference conclusion unless we control for, ideally, all other variables, all other factors that influence our Y variable, unemployment, and may be correlated with, in this case, our treatment variable of the federal funds rate. So again, for the student in their first time class, you're going to have fairly minimal expectations, right? You want to have 3, 4, 5 sensible control variables. And in this case, you can get this right out of kind of introductory macroeconomics, right? You want to think about, well, inflation and unemployment are related through the Phillips curve. Output obviously is going to be having an impact on unemployment. Then you can think about, well, maybe the volume of trade deficits, exchange rates, longer term interest rates, financial markets, all these things are correlated with each other and with unemployment. So lots of different places to go, but that kind of gives us maybe a little shopping list when we start to poke around our data sources. So before we get into that, what the ultimate goal here is, because we're in a time series framework, is to have a data set that looks something like this, right? That you see up there, where we have our key organizing principle being the date, right? So we want to have the unemployment rate, the inflation rate, some measure of output, and then our additional X variables all measured at the same time, sequenced by time or by date. So that's kind of the mental picture of what we're going to try to construct. And before we get too far into it, note in this example I have monthly data, right? But that's really the key question before we get too far into it is, what frequency should our time series be in? Can we get daily data? Do we have to use annual data? All other things held constant, you generally want the highest frequency possible, right? So that'll give you a larger number of observations, a larger sample size, and you'll be able to capture more of the dynamics. But that's not always going to be possible. Okay. So the website we're going to go to is this Federal Reserve Economic Database put together and published by the St. Louis Federal Reserve. When in doubt, just Google Fred data, and it'll take you right here. And it's going to be pretty simple from there. Just as long as we've got kind of the categories, the types of variables that we're looking for, just go ahead and search in the search bar and pay attention to the options that are available. So let's go ahead and navigate over to Federal Reserve Economic Database. And we've got kind of some latest updates down here. It's all bad news, June 2020. So we won't even look at that. And let's just go ahead and put in unemployment into the search bar. And what we'll see is a lot of different measures of unemployment that are available to us. So we have unemployment rates broken down by demographics. Regionally, we have unemployment numbers, the raw numbers of claims, etc. But there's not much of a reason for us to go beyond the first item on the list here, which is the unemployment rate. So if we go ahead and click on that, it'll give us the nice little kind of familiar cyclical graph. Everything's fine, and then holy smokes. Again, we're not going to get into what's happening in the economy right now, but that little spike there is the May-June 2020 scenario. And then if we scroll down a little bit, we see we have a nice little description, right? So this is monthly frequency. And since this is going to be our dependent variable, we're going to want to have all of our other variables match that same monthly frequency, right? So what I would recommend is starting here, just copying all of this. It's probably more information than we need, because we all can kind of define the unemployment rate, but it gives you the original data source, the description of the variable, is just copy that, move on over to a Word file or a Google Doc, and paste it, and this will now become kind of your data appendix for the paper that you're writing, because your readership, primarily your instructor, is going to want to know where you got your data and what exactly it is. And it also has our code. So this right here, unrate in all caps, is the Federal Reserve Economic Database code for this variable. And I'm going to put it in line with these other variable codes, right? So we'll come back to that in a second. So if we go back to the website, you will see that there is a button to download the data. We are going to ignore that, right? So if we hit that, we can download it as a delimited text file or an Excel file, but we don't need to do that, right? We'll be able to extract it straight from inside Stata as long as we know this little unrate code, right? So what you'll do now is go back to the search bar and say, now let's search for output, let's search for inflation, etc. And you'll get something like this. You would copy and paste everything over here, and then you'd have this sequence of codes. And that's all we're going to need to grab the data in Stata. So let's copy this, go back over to Stata, and we are going to use the freduse command, right? So our Stata commands to get us going. The first thing is, if you haven't done this already, we need to install this freduse package that kind of integrates our Stata with that Fred website. So ssc install freduse. I already have it installed, but it's going to work through that. And then the command itself is just freduse, and then you list out the variables separated by a space, no options, no commas, no semicolons, nothing fancy. And we hit enter, and soon enough we see our Stata file here populated by the variables that we wanted. So we've got the federal funds rate, we've got industrial production, we've got GDP, we've got the CPI, and we've got unemployment rate. So there's our freduse command. As always, just to make sure things are as we expect, let's open up the data browser. And we've got some things to think about here right off the bat. So first off, we have two date variables here. We have date and then date in. And you'll notice the first one is in kind of the usual year, month, day format, but it's also in red font, right? So remember, when you see red font in your data browser, that means Stata is reading it as text, as a string variable rather than as numeric. So that's going to be a problem. But you see, oh, well, our other variable here, date in, the in for numeric, is in a format that Stata is able to read. And it is in day, month, year format, but the same corresponding dates. So that's definitely something we can deal with. So we'll come back to that in a second. The other thing you'll notice is a whole bunch of missing observations, right? So whenever you see that little dot in a data cell in Stata, it means there's nothing there, right? So industrial production started way back, the available data started way back in 1919, but GDP, CPI, unemployment rate, Fed funds rate, they don't start until later. So the command goes back as far as the longest time series. So if we scroll down, we'll see those other variables start to become populated in about 1947 for CPI, 1948 for unemployment rate, 1949 for GDP, and aha, here's the next issue we want to look at. If we weren't paying attention to data frequency, we would run into this problem. So GDP is always only available at the quarterly level, whereas our other variables, what we can see here, CPI, unemployment, and industrial production, are all monthly. So what we would do is, if we tried to run a regression or do any analysis that combined these variables together, it would only be every third observation that coincide, and these intervening observations would be missing all the way across. That's not great, right? So there are ways to interpolate, I said, those intervening monthly observations. That's not ideal. The other option would be to collapse the monthly data to the quarterly level. And if your key variable that you absolutely couldn't live without was quarterly, that would be all you could do. There are commands in Stata to do that. But for our purposes, and what you'll generally see is, let's kind of forego using GDP as a measure of output and just use industrial production, which does measure something else, but they are highly correlated and generally do a similar job. So the only reason I put GDP in here is to show you why we wouldn't do that, right? So pay attention to your data. And then just to make sure, there it is, federal funds rate jumps into the game here in 1954. So when we actually put all this together, it would only go back to 1954. Okay, so now the next issue is that date variable. So what we're actually going to do is create a third date indicator variable that is in exactly the format that we want. And the only problem, the only thing we don't like about, bring back the data browser. There we go. The only thing we don't like about this date in variable is that it does have the day as well as the month and the year. And Stata is going to get a little confused there and think that it's dealing with daily data. So we want a variable that just has the month and the year. And then we'll use that to organize our data, and that'll open up all of the time series options that will be available to us. So back in Stata, the command that we will use here, and there's various ways of doing this, but let's go ahead and generate a new variable called monthly date. And on the other side of the equal sign, we're going to use this function, mofd, that's going to transform whatever we put into parentheses into a Stata readable monthly date. So let's put in that numerical date variable, date in, into that function. And let's go back to the data browser and see what we have. Well, okay, let's go back all the way to the beginning of our data, and we have, this is a little bit odd. We have monthly date of negative 492 corresponding to January of 1919. Well, the Stata formatted date convention is that it's a number representing the number of periods since January 1960. So I'll take the word of Stata here, but what this indicates is that between January 1919 and January 1960, there were 492 months. So technically, that's all we need to do. We now have a numerical sequence that organizes our data by time, but if that shows up on our plots, right, we can't tell exactly what that means. So the next step is to turn this into a to go from just a Stata readable date into a human and Stata readable date. And for that, we just use the format command. So let's go ahead and format this newly created variable, monthly date, and then we use the code here, %tm. So the m is the important part. It's telling Stata that these are months as our organizing principle. So now the data browser one more time, there we have it. So 1945, month 11, right, all the way back to 1919, month 1. Basically all we've done is gotten rid of the 01, right, that was that default, and telling Stata that this is measuring monthly sequences. Right? And then the very last thing we have to worry about is telling Stata that what we've done is create this variable that organizes our data. So the tsset command, monthly date, that's not going to change anything that we see. All it's doing is giving that information to Stata that when I ask you to do something, note that all of my data is organized, is sorted by this monthly date. So I'll link to the video on taking the next steps, right? So if you want to do a time series plot, you're all ready to go. It'll start to look nice right out of the box. And then more advanced regression techniques as well. So one last thing that we should have been doing all along, right, is because this is in an effort to generate a kind of long-term project and we're doing our first steps, is you always want to have a do file editor open as you're doing this, right? So that do file, and again, I got a whole video on that, I'll link to it. It's just a way to record your useful commands, right? So it'll make this an entirely, this project, someone else can replicate all of these results. So the first command that we're actually going to need to use is the freduse command. So if I copy that, go over to the do file editor and paste it, now everything that comes after this will be based on that data. So your readers, the editors of the journal that you're submitting your project to, or your instructor is going to want to see this, and it's just a really good practice, right? So 2 years from now, you're doing another time series project and you have to deal with dates, and you'll say, oh, I know I did that somewhere. We'll go dredge up this do file. It'll have exactly that sequence of commands ready for you. So if you have any questions, leave it in the comments. If you have any suggestions of other topics you want to delve into, leave those in the comments as well. And otherwise, have a great day. Thank you.